Now that we have a number of ways to solve quadratic equations, we're going to throw back to a property that you've known for a very long time, and that is the Pythagorean theorem. Remember, if you have a right triangle, then the two sides that meet up at the right angle, these are called legs, and the diagonal that is opposite of the right angle is called the hypotenuse. Often we say one of the legs is an A, one of the legs is a B, and the hypotenuse is always a C, giving us the formula A squared plus B squared equals C squared for any right triangles with legs A and B and hypotenuse C. Let's look at this next example. A ladder is leaning up against a wall. The ladder reaches 12 feet up the wall. The base of the ladder is resting 5 feet away from the wall. What is the length of the ladder? So this is a pretty straightforward question, but just remember we do know Pythagorean theorem and we can apply it to other things. So here's the wall right here. Here is our wall, and this is the ladder that is on the diagonal, right? Well, what do we know about the wall? We know that the ladder, where it reaches all the way up the wall, is 12 feet high. And we also know that from the base of the wall over to the end of the ladder that's on the floor, that is 5 feet away. And they're asking us, well, what is the length of that ladder? Well, we're going to assume that the wall and the floor are square. And so based on that assumption, we can see, oh, this is a right triangle. We can use Pythagorean theorem. So the length of the ladder squared, c squared, the hypotenuse squared, is equal to one of the legs squared plus one of the legs squared. In this case, when we put everything into our calculator, 5 squared plus 12 squared is 169. How do I undo a squared? I square root it. So the length of the ladder is going to be either positive 13 or negative 13. Well, obviously, the length of a ladder cannot be a negative. So in this case, we don't need the plus or minus. We will just get that the length of the ladder is 13 feet.